Hello everyone. In this video we are going to look at assembly in Fusion 360, and to demo that I have chosen a slider crank mechanism here. This is the crank, that is the conrod, that's the slider, and this green member is the support, and I have created a pin afterwards, and this is the motion of this mechanism as you expect, right? So clearly the crank is capable of spinning 360. The conrod spins and moves, and the slider only has one motion along the y-axis. So if I want to create this assembly, as you know, in Fusion 360 there is not a separate tab that you see up there for assembly, and assembly has its basically toolbars, one toolbar within the design. So you don't have assembly here, you don't have assembly up there. As I said, it's within the design. So how do we do it? In this case, let's say that I made the components ahead of time. So here are the components that I made. I made the slider separately, the support separately, the crank and the conrod, and now I want to put them together. Okay, the first thing is to insert these components into a file so I can assemble them. And there are two ways you can do it, either from your cloud here, this data panel. You can right click on the part and you say insert into the current design, and it brings them into here just like that. Here you can use the transform tool or move copy, and you can move them or you can rotate them and put them anywhere that you want. So let's say here I did that, and you see that is added as a component, and you see next to this component there is this anchor sign, which means that component is fixed to the background. So now if I click on this guy and try to move this body cannot be moved. Okay, so this body clearly cannot be moved. If I go here, right, and that is this body is completely fixed, and that's because it's the first component that you inserted. But if you want, you can right click on it and use this option, says unground from parent. Ground here means anchor, fix. In SolidWorks we call it fix. Unground means float it. So now this guy should be movable, okay? But if you ground it, then it's not going to be able to move, and many mechanisms they have typically a fixed part. So here I ground it back, and now this is not going to be able to move. Okay, that's one way to bring the parts in and fix or float them, or ground and unground them. The other way is to go here under insert and insert a component. Then it goes to basically your list of the files that you have, and here let's say I want to bring the crank, so I bring the crank, right, and it allows me to move it and place it somewhere appropriate like this. And then I can also go ahead and bring the other one, let's say in this case conrod, and then I also have the slider. So let's hold down control, right? Let's see if I can bring both of them. If I hold down control, can I bring both? Seems like not. You're doing it one at a time. Okay, so that is the conrod here, and let's just to repeat that, I bring the slider through this method again, insert into current design. There we go. So I brought my 4 components here, and I'm ready to assemble them together. Okay, so let's just start with the crank. So we go under assemble and we apply a joint. We create a joint, a revolute joint between this hole here and that kind of pin, and we allow the relative motion between them. So we click on joint. First we go to motion and pick the type that we want. There is rigid, which fixes 2 things together. There is revolute, there is a slide, there is cylindrical, pin in the slot, planar, and a spherical or ball joint. So here we want the revolute, go here, and then I pick the front of this, and I pick the front of, and you see there are different places that you can pick that size or this size of basically this pin area, you see? So you can pick here, I pick this, so it also makes those coincident with each other. And I guess that's all I need to do. If you do Philip, right, you do the anti-align, and that's not what you want in this case. And the origin mode is simple, although you can do between faces and intersection and so on. And you can give it an initial angle here. Right now there is no angle. You can even give the surfaces offset. So for instance, if in this case I say align X 5 mil, you see now it moved up and down. Or no, I say give it an offset align, let's say Y, right? And if I say give it an offset about Z, Z is the axis of the pin, right? And if I wanted to get out, I say -5. So I can do all of that, and I can also give it a rotation. Say I want 30 degrees, okay? And there is 30-degree rotation. So I can do all of that. But since we can move it later, I'm fine with that. So now the crank should be installed, and you see that as you drag it and move it, it does properly move. Okay, so this is the crank. Now we go for the con rod, and we do a similar thing here. Again, we go ahead and click joints, and we go to motion. It's already on Revolute, the last one. And this time we want the front of this hole on the crank to match this back hole here on the con rod. And we okay that, and there we go. You see now it is also pinned down, and the motion is what you expect to have. Now we go for this slider, and again we need one extra revolute joint. So here we go, revolute, and this time we pick this and this, and we okay it. There we go. So now this should move with it. The last thing we need to do is to apply a planar joint, okay, which is between the bottom face of this slider and the top face of the support. So between basically this one and, let's see, it allows me to pick it. There we go. Let's see now. It doesn't crash or anything. There we go. So now we should be able to show the slider crank motion. There we go. Okay, so here we put the slider crank together. Now, of course, we don't have a pin here, and it's a good idea to add a pin. And the thing we have done so far is called bottom top assembly, which is creating the components individually and then bringing them and putting them together. Many times it's advantageous to do top bottom assembly, which is creating the parts inside the assembly while you are still seeing other components and you can using their sketches and entities. For instance, if I want to create this pin, I don't need to close this, go open a new file, make a pin, and then insert it here. I can do it right now. And to do that, you just go under create and say new component. And just give it some name. So I call it maybe pin 1 because I already have a pin. And okay that. And now you see that when pin 1 is created, the rest of the assembly kind of becomes transparent and becomes inactive. So this transparent means these are inactive because this component is the active one. Whatever component that has the circle and dot, that is the active one. If I want to go back to the total assembly, right, which in this case is unsaved, I can just click here, and now you see the whole assembly becomes active again, right? Or if I want to make this one active and edit that, I just click here on edit in place. I just click on this and basically edit that in place, right? So let's say, for instance, I want to edit the support. So I click on this, and capture position means stay where you are, okay? I okay that, and now you see I'm in the support part, and let's say I want to make this guy maybe a little bit wider, so I go to edit feature, And you see on one side it was 20, so now I make it like 25. Okay, right? And then once I'm done, okay, with that, I can go back. So the support is made and finish edit in place. Now if you look, last time the end of this was flush with here. Now I have an extra 5 mil room, right? Because I edited that in place. And let me save that here. I just call it temp because I already have this. And now, as I said, so I showed you how to do edit in place. For this one, it's still empty, it's blank. I have to create it. So I click here, make this active, and then go inside of it to be able to create it. So let's say I go to this YZ plane and start to sketch. And this is the part that I'm talking about, the advantage. So if I need to make a pin that is the same size as these circles, these circular holes, okay, I want the same diameter, okay, and here I'm not going about any tolerance right now. So instead of drawing a circle and measuring those, or knowing how much was the diameter of those, and making sure the diameter of this circle for this pin is the same as those, this is the better way to do it. I click on this circle, I can pick. You see, I can pick all the edges or faces or anything of those previous components. I pick this guy and go here to create, and then what? I project it, just like that. And this time I keep the projection link. Why? Because later if I decide to make that pin a little bit bigger or the hole bigger, automatically this pin will also get bigger as well. Do you see that? Now in this case, since I want to use it on this guy, it's better to do that, although they're all the same size. So this time it's better to project this one, right? And keep this projection link, so any modification to these holes will automatically change the size of the pin. There we go. That's all you need. You got the circle, and now you extrude it, and this extrusion should be 10 mil, and we okay that, and I'm done. That's all I needed for the pin. Now I click here and go back to what? Go back to temp and make it active, and now the pin is also there. As simple as that. This is called basically top-down assembly, or creating parts within the assembly. Now that I have this, it's time to basically assemble that as well by a joint. Now this time I do not want this to spin necessarily within the hole, or I can. So one thing I can do is, instead of planar, this time I use what? I use a rigid joint. And then I rigidly attach what? This pin to the conrod, like that. Okay? And I okay that. And you see there is E next to it, that symbol is not really E, it's a rigid, but it looks like an E. So that is a rigid joint. That's a symbol of a rigid joint. So now if I spin this, the rotation of the conrod and the rotation of that pin are going to be exactly the same, because those two objects are rigidly connected. There we go. So we are done. Now, a few extra things to make this video comprehensive enough. One is, when typically you bring the components first time into the assembly, if you did not apply different colors for them, then all of them will kind of look gray. But if you want, you have this option here. Let me show you under Inspect. It says Display Component Colors. If this option is active, then it will automatically apply different colors to different components, so you can distinguish them. If this is not on, look, then they all look like this. They're all gray. So when you bring them in, if they're all the same color, go ahead and do a Shift N. And there we go. Okay, what else? One of the things that is important in assemblies is checking for interference, whether the parts are penetrating into each other and they have overlap or not. Now, in this case, you might say, what is this extra thing that you made? I deliberately made it so when you bring this guy back, that extra protrusion will get into the support. As you can see right now, you see there is right now interference. So I wanted to show you how to check for interference. So right now, in this position that there is interference, you go to Inspect and check for interference. if it says capture position, means do it in this position. If it says revert position, means put it back to the original position. So you see, if I go revert, it goes to what you started with, not after you brought it all the way back. So you can always apply a capture position or revert position. And in this case, I do want to do it in capture position. So make sure that in this case, you do it in capture position. And then let's go ahead and find the click on the objects we want to check interference. Now be careful here. This whole thing is one single object, so it doesn't matter where you click. So I click here. For this one, you see it has two different pieces. So if you click on this, there will be no interference. You have to pick this part. And now you say compute, and there we go. You see here, it found an interference volume for me, and it even gave me the volume of it. You see, there is interference in this case, and that's no good. Okay, but if I move it to another position like that, and I redo the exact same thing here, so between again this one, and say give me interference, hey, no interference. Okay, so this is one thing that I wanted you to see. The other thing you might say is, wouldn't it stop the motion when there is interference? And the answer is no, it doesn't. Look here, if I move this guy and it penetrates into the other object, it is not going to stop my motion. It allows the motion to happen. So you might say, is there anything you can do so when there is interference, it does not let you move? And the answer is yes. Where under assemble, if you go and activate this guy, enable contact sets, okay? Enable contact sets or all contacts. So everywhere you see a contact, go ahead and stop the motion. So now I grab it and try to move it again. So let's grab this. Now look here. As soon as I reach the area where those two faces become tangent, look, right now, here, let me use a top view maybe. You see, they're reaching. It does not let me move anymore. Look, this is the maximum. I'm just really trying to use my mouse and move this guy forward, but it doesn't go any further because I enabled all of the contacts. So this is like my mechanical limit, right? These are like locks, mechanical locks on the motion, and they do not go any further than that. And one of the good things about it is it shows the values of the joint. So it says, hey, this joint is rotated 158, this one is rotated negative 146, right? This guy moves 35, that one the same, negative 15. So all of the joints that you have under here, it can show you their values, the joint variable values, as you move. And so it does real-time computation of joint variables, which is really powerful. So if somebody says, what is the maximum angle that the crank can go in here, is 158 degrees. It cannot go anymore. You don't need to do any measurement. It's already there. By the way, any joint that is under joint, you can right click on it. You can edit that. You can delete it. You can click on animate the joint. Now for this joint specifically, it does this crazy thing. It fixes this member and it rotates the other one because the order that these two members are selected is basically backwards, but you can always fix that. So let's say here, this is this one, or if you want to, let's say, look at this, right? So say animate this. And of course, right, when you do an individual one, it's not so super meaningful. So can I get this to create a nice animation or motion for me? Yes, I'll show you that one as well. But before that, a few other things about the joint. So if I click on this revolute joint, a few other things that you can do other than, of course, suppressing it and so on. One of the things you can do is the drive joint. And drive joint basically means I specify exact value for the joint variable instead of just manually grabbing it. Let's say I want to put crank here at exactly 60 degrees. How do I do that? I click here and it says, okay, you pick that joint, fine. How much do you want that angle to be? and I say what? Let's say negative 60 degrees or 60 degrees, right? So that's 60, and I say negative 60. There we go. You see, it exactly take it for me to the 60-degree angle. So that is one thing. If you want to go to a specific variable, you can do that. The other thing you can do is to lock a motion. If you lock a joint, then the joint basically becomes like a rigid joint. Now, in this case, I cannot lock anything because I only have 1 degree of freedom. And as soon as I lock a joint, then nothing can move, right? So we can try it, right? Let's say lock this middle joint here. If I lock this guy and now try to move, you see nothing moves. So this lock joint is good in systems with more than 1 degree of freedom, when you only want to look at the effect of one of those motions and not the other ones, right? Like a robot or, I don't know, planetary gearbox or anything. So locking a mechanism with only one DOF, if you lock any of them, you're going to make it a structure. So pay attention to that part. And another thing you can do is to put limits on the joint motion. So here you see I have edit motion limits. Right now there is no limit for how far this can go. It can go full 360, but let's say I only want to go from 0 to 180, or let's say 120. No more than that. Okay, so if I okay that, now look, you see, look here, it doesn't go up because that's the 0 angle. And then when I move it down, if I grab this guy and move it down, then all it can do is to 120, and then it locks. So you can put some joint limits on the joint as well, right? Or if you're done with it, you can go ahead and undo those. Okay, so now this joint has no limits, so it should be again able to fully move, right? So let's see, there we go. Seems like still those limits are there. Let me okay that. I guess I forgot to okay that, so now there we go. Now I should be able to fully move. Okay, so this is another thing I wanted to show you. Now let's keep moving. One other thing you can do is to change the joint origin, or pick the joint origin if you want, which is not super necessary right now. Another thing is rigid groups. So if you want to connect more than two objects together as a rigid object, you can do that. So this rigid group is when you have more than two. If you have members that have contact with each other, then you define contact with the tangent relationship. Okay, so if you looked at the joints, there is nothing for contact. There is rigid, revolute, slider, cylindrical, pin, slot, planar, and ball. But if you have, let's say, a cam and a follower, which only have a simple contact, then you want to use a tangent relation. So this is good for those cases. And then there is another one called motion link. This is when the motion of one joint is related to motion of another joint, okay? Now in this case you don't want to do that because, for instance, the rotation of this crank and the X motion of this, or Y motion of this block, are related, but not through a simple relation, through a lot of trigonometry functions, okay? So in this case, it's a little bit more complicated. But if you have more than 1 degree of freedom and you want like your second DOF to be a function of the first DOF, then you can do what? You can basically do motion links. Okay, and finally I want to show you, or maybe finally I want to show you this one, motion study. This is probably what you have been waiting for. So here we click on motion study. And here we can move a joint and create an animation. Let's say I want to look at joint 1. So I pick joint 1, and now these are basically the this is from 0 to 100% of the animation, and then the y-axis will be the values of the joint rotation. So here you manually create the joint, the revolute joint motion versus percent of the animation time. and then you can change the speed of it, and then you can see in which mode you want to do animation, one way, forward, backward, or in a loop, and then you can play it. So here you click on this point here, and let's say at step number 10 out of 100 steps, I want the angle to go to negative, let's say 20 degrees. There we go. And then let's say at this step, which is a step 20, can modify. I want to go to negative, let's say 40 degrees, and you enter, and you can keep basically adding all of this, right? And so on and so forth. Let's say at 35, I wanted it to be at negative 60 degrees. And once you're done, so seems like one of them I didn't do, that's fine. You have to click outside. If you do this and not click outside, then that is not going to be effective. So something like this, and then maybe this one, step 88, let's say 85, I want to go to negative 175 or 160. And finally, at this very last step, I want to be at negative 180. Okay, so you manually create the curve, and now you're ready to go. Let's go ahead and play it. And you see that it does it. And if you want, you can put it in two-way mode like this, right? So it shows the forward and backward motion, or you can put it in a loop. And here it just keeps going in the loop now, and you can also change the speed of the animation. Now it's very simple motion study, but still it can show you the purpose of the mechanism. Okay, hopefully the video was useful to you, and I will see you in the next video. Thank you.